Hello, my name's Tally and I'm an outreach officer at Aberystwyth University. And today I've put together a video for educators on how to use the microbit within education, whether it's in a classroom, homeschooling, or within a group or club. So this video comes in three parts. We have, first of all, the introduction to what the microbit is and what it's capable of. The second part will be looking at how to use MakeCode, which is a software designed for programming the microbit in block-based language. And finally, we'll be taking a look at the microbit classroom software, which has had a relatively recent update, and what it allows educators, teachers, club organisers to do with a group of kids in one place. So let us get started. What is the microbit? That is the very first question I'm going to answer. The microbit is a small computer. It can be programmed using a variety of different languages. However, we will be using the block-based language for this video as we are just getting you started. It is quite a nice follow-on from if you've done programming in Scratch with them before, showing them the similarities of block-based languages. Now, microbits have a lot of different inputs and outputs available, and that depends on the version of the microbit that you have. What do I mean by that? Well, the microbit has been around for a few years, and I do know that schools have come across older versions as well as been collecting newer versions. Some schools now have a combination of the two, and it is quite handy to be able to tell the difference between the two versions because there are differences in what they are capable of. The version 1, as you can see on the left here, has less functionality than the version 2. As you can expect, they've been updating, upgrading, and adding things to it. That does not mean that you can't use the version 1. If you've got the version 1, there are a lot of things you can still do with it. So how can you tell the difference? Well, I've got images here of the two of them next to each other, and you can see some instant visible differences. So the very first difference is that the top microbit logo, that sort of oval, this oval symbol with the two dots in, that's the microbit logo, on the version 1 is the same color as the corner. The reason is this is just painted onto the version. It's just their logo. However, in the version 2, it's imprinted in gold because it's been switched over to a microbit logo shaped touch sensor. So there's an additional input on the version 2 with this touch sensor. The other visible difference is across the very bottom. These bottom gold sections are called pins, and these allow us to connect additional things to the microbit. And you can see on the version 1, you've got that flat base to the pins, whereas on the version 2, you've got these nice notches. Now, the reason they've introduced these is if you're using these pins, crocodile clips can slip quite easily. So they've put these notches in to help with grip. However, these little bars in between these are also pins that can be accessed using a breakout board for the microbit, giving you, instead of those 3 programmable pins, 20 programmable pins. But that is something to look at once you've gained your confidence with the microbit. I do like this particular infogram for demonstrating what the microbit is capable of. Now, if you can tell, this is a version 2. It's got the gold touch sensor and it's got the notches in the pins, but I will go through the differences. So if we work our way around from the top here at the touch logo, we know that's only available on the version 2. That's an input that can be used as an additional sort of like button that just requires touch. The USB connector goes in at the top. This is how you connect it to the computer, which will provide it with both power and allow you to download programs to it. You have a microphone or sound sensor, which is only available on the version 2. You have the buttons, which are on both. You have 25 red LEDs that can make up a screen, which allow you to put on images or messages on the screen. On the back, then, we have the radio antenna, which sends and receives messages, which allows you to communicate between more than one microbit. It's also an interesting talking point because we've been looking at inputs and outputs, and the radio antenna is both because it can be both. You've got reset button on the back. You've got the battery socket connector that allows you to connect it to 3 volts worth of batteries. You've got the processor labeled on there. You've got the speaker version 2 only. That produces sound. For some teachers or educators, it might be beneficial to have a version 1 if you've got a lot of people working with microbits at the same time with programs that use sound. There is also an inbuilt compass, which is great for doing little activities involving such things as hiking or map orienteering. And then there's the accelerometer, which is a little bit of a mouthful, but it's a really great sensor to have in the microbit. It allows us to use tilt functions, so it will know which way it's being tilted. It knows which way up it is. But the best thing for if you're using this in science lessons is that it has the measurements for its acceleration. This is great if you want to do an experiment such as parachute challenge. Basically, what it can do is you can drop the microbit. It will send the data from the accelerometer. You can have it sent by radio to a microbit plugged into your computer and get live data on the screen showing the success or lack of success of a parachute. And then across the bottom, as we've already mentioned, you've got those pins that allow you to add even more inputs and outputs to the microbit. Now, although I'm saying that you might have them in the school, it doesn't matter if you don't. If you don't have microbits, if you've missed out on any of the schemes to get microbits into the school, or maybe you're homeschooling and don't have access to one, that's fine, because the Microsoft MakeCode, the software designed for programming, it includes a simulator, which means that you can test the programs without needing access to a microbit. And the simulator can even replicate some of the components that you might want to connect to it separately. We use this a lot when we're doing our online clubs. It allows them to work at home without needing an actual microbit, and it allows them to still learn about programming, but it does cause some restrictions. Obviously, you can't do live data collection without a microbit, and you can't test to make sure it will work in the real world without a microbit. But to get started and to learn how to program and to find out if this is a piece of equipment that you would want to invest in, you can use MakeCode. So, using MakeCode links in nicely. MakeCode for microbits. Now, this can be accessed online. It's in browser, makecode.microbit.org. There is, I want to make a note of this now, a desktop version of the software available for offline usage. However, it does lack some functionality that you need to be aware of. You cannot access the extensions if you're offline. So if you haven't included an extension in the program, when you've saved it, it will not be able to access it whilst you're offline. The other thing is you can't do live data collection. If you're not too sure what I'm talking about quite yet, I'm going to cover it now. So let us now have a quick look at the MakeCode. Okay, so when you load up that web address, makecode.microbit.org, you get a page that looks something like this. Now, if you've not used the microbit before in the past, or the browser's not been used on MakeCode before, you won't have any of these extra files here. These are all my save files here. You'll just have the new project button right there. Now, this is an option that you can make as an educator, whether you're a teacher or a parent, as to whether or not you have your students sign in. They can use school accounts, Microsoft accounts, Google accounts, to connect themselves to the microbit, and that lets them use and see their files that they've produced no matter which computer they did it on. So if you're in a classroom and you have a classroom set of laptops, unless they get the same laptop or computer every time, they won't have access to their previous files or have access to someone else's. Let's go and load up a new project. First thing it asks is to give it a name. So I'm going to quickly name mine demonstration. And it's going to load this up. This is the MakeCode editor. Let's load it up. On the left here, you can see the microbit. This is the simulator. This is going to show us what the program is doing as we alter it. On this side is the canvas where we have the program. And between the two, we have the menu, the blocks menu. And this is broken down into basic blocks, which are your screen, where you can show messages, show images, clear the screen. Also, it has these in here in case you've accidentally deleted them from the program. Just as a brief reminder, you should only ever have one of each. And it's got the pause in there as well. So if I was to put one of these in, this show LEDs, this allows us to draw our own pictures. So I'm going to draw my own picture. I'm going to do sort of a smiley face. And it will then load up in the simulator. There we go. We can actually see it on the screen on the simulator. So as soon as we make a change, this will update and give us what the program looks like and restart every time. I could then put in here to change it to a different picture, and there's a whole range of pictures already preset that you can choose from the icon list. So we can have that go there, and that will mean that when we start the microbit, it will show the smiley face, and the moment that it's finished that, it will go to that, and it will stay with that. Perfect. So we then have input menus. We have the buttons. Now, if you notice, if I load that back up again, there's only an on button A pressed block. Take note of this because some learners struggle to find how to change it to B, and the answer is you get the A1 and then you use the drop down menu to get B. Now, if you notice, there is an option on the microbit to program it to do something when you press both buttons A and B, and in the simulator, we can only press one because we're using the mouse. So it's quite clever in this regard, in that if we say that we want to use buttons A and B, the simulator gives us a third button option. And this, if we press on it, you can see lights up both buttons A and B. It allows us to single click in a location that will activate both buttons. There are other things that will be added if you were to use the on shake function, if you're going to use the accelerometer. If you're going to use the on shake function, you're going to use the accelerometer for either shake or tilt or position or movement. As soon as you put that in, you now have this option of shake where you can click to replicate shaking the microbit, or you can just move the mouse around it and see different levels of shake and motion. And now we've got a fully dynamic idea as to the movements that are happening to your microbit and what effect that has on your program. And the same goes for sensors. If I load up one of the version 2 sensors, if you notice, it actually says these blocks are only for the version 2. Anything above this you can use on both microbit versions. Anything below that line is only available for the version 2. So if I was to do it on loud sound, we now have more stuff appearing on our simulator. I now have this microphone lit up at the top to highlight that the microphone is now active, a number, which is the reading of the microphone sensor, and then this bar, which allows us in the simulator to recreate volume levels. So we can set it to quiet, silent, or very, very loud, just to test what happens with our program and the different sound levels. There we go. So the simulator is quite dynamic. It's quite fluid in the way that it adapts to what you have in your program. In regards to actual programming and how to make a basic program, I'm not going to go into that right now. There are some tutorials on the microbit page. If you click on the microbit at the top there, it takes you straight back to the home page. It's automatically saved our file and allows us to start a new project. But on here also, you can see there's lots of tutorials. If you're not sure, have a play around on the tutorials. If you have a look at the web page that is linked to this video, you will also find that we've also put together some classroom resources to get you started with the microbit with actual programs and ideas as to what sort of programs to do. So we've now had a look at how to make a program. Once you've got a program, you then need to put it onto your microbit. Now, microbits need to be paired to the computer before you can download directly from MakeCode. If you don't pair them, if you just press the download button, it's just going to go onto your computer. So I'm going to take you through quickly how to connect a microbit to your computer. So here I have a program that I've put together, and I want to put it onto the microbit I currently have plugged into my computer. But the first thing you need to do is you'll need to connect the microbit, because if you just press download, all it will do is put this program file onto your computer. It's going to go straight into your downloads folder. Where you actually want it is onto the microbit. And you've got this option here. You go to these 3 dots next to the download and you connect the device and then follow the instructions that come up on your screen. And once you've got it all connected, followed the instructions and got it all connected, you will now notice that the download symbol now has the microbit logo next to it. That's telling you that it's going to download it to the microbit. If it hasn't got that symbol, it's not going to download to the microbit. Now, this is one advantage of if you're using the offline desktop app, is that you don't have to pair the devices. It will automatically connect to a microbit that's plugged in and automatically download straight to it. But now I also want to show you another thing, which is the live data collection. So this program here is taking the light level from the sensors on the microbit, and then it is putting it into what's called the serial monitor. That's an area on this computer where we can see the data. And you'll see down here, I've got 2 show datas going on here. One's for the simulator and one's for the device. So if I want to access the live data from this device, now we got a graph and we've got these readings appearing at the bottom. So it's giving us the readings as they come through. At the moment, it's measuring light level and I have the microbit in the dark. But if I start to introduce light, we'll hopefully start to see the value go up. And you can now see that the value is quickly shooting up. I'm going to see if I can get it to the maximum. I'm currently using a torch on it. And even with a torch, I'm struggling to get it up to 255. The highest I've got it to, if you look at the graph, is 246 up here. You can see the top of the scale and the bottom of the scale. Now, as an educator, there is something to pay close attention to. If I start to move the light away and drop the value down, we can start to see, let me just wait for it a moment. The thing you need to bear in mind when you're trying to explain what's going on in these graphs is that the scale is dynamic. So if you're only getting low numbers, the scale will adjust on the axis to represent it. So as soon as this gets to the point where it's all smaller values, sorry, my torch is wobbling a little bit, hence the slight variation in numbers. You can see the axis is scaled up automatically and the graph looks like it's even bigger and brighter. But actually, if you look at the value of the scale, it's only going from 69, in fact, now 49 to 0. We've now covered how to download to the microbit. One note there, microbit can only hold one program at a time. The moment you put a program on, you overwrite the previous program. And we've now had a look at the live data. I've just demonstrated there how you can do it just live with a microbit that's plugged into my computer at the moment, just to give data from the microbit plugged in. If you wanted to do something like a parachute challenge, what you could do is you could program a microbit to send its accelerometer data via radio to another microbit plugged into the computer that can then collect the data and put it into that graph. If you want to know more about that, there is a teacher pack for our parachute lander challenge style setup on the webpage associated with this video. So now let's have a look at the microbit classroom software. This can be found at classroom.microbit.org. So what you can do here is you can set up an online classroom, you can see all your pupils' work, you can share a program with them, and you can edit their programs. That's a new feature of the latest version, is that you can actually edit their programs and they can see the changes that you've made. These classroom sessions can be saved and reopened at any time as well, which means that you don't lose the work on closing. As long as you save it, it will save the web page and all the students' work within it. So let's go and have a quick look at this. This is the microbit classroom. This is the screen that you'll come to. You can see I've already had a session opened up here called Test Classroom. I could reopen that if I wanted to. However, we're going to create a new one just to show you what it looks like. So you start a new session. I'm going to put in the date. And you can choose whether you want it to be a MakeCode editor or a Python editor. We're looking at MakeCode because we want to do it in the block program. We can also set a starter code. So you can decide if you want to give them some code to start with to get them going, or whether you want to leave them with the blank canvas. For this demonstration, I'm just going to leave the blank canvas. I'm then going to tell it to start the session. And simple as that, we now have a classroom. This shows me my program so far. But what I could do is I could edit this. If I go into the editor, it's exactly the same as the generic MakeCode online. But the difference is you can send your code to the students. Just bear in mind that when you send code to a student, it overwrites the code they've got. So just be careful. If you're sending the code to all students, you'll overwrite everything they've done and replace it with the code that you've sent. Now, the other thing is obviously at the moment, my classroom just has me in it. So what you can do is you can get the joining details and you can put those up on the screen. You can share them with your students. They go to this web address, microbit.org/join, and then they enter this classroom name. And then there's a password as well. And then once they've connected, you can then see each of the students down this side list. And you can then select their programs. You can look at them. You'll have the same options as you have on your own code here. You will be able to look at them and you'll be able to edit them. So when you've finished your session, you can save it, and you want to probably save it as a file. A report will not allow you to redo it. That's a Word document, which just shows final images of the student's code. Save the session as a file, and then I can reopen it and see everyone's work still, and I can share the link again and they can rejoin and they can continue working on their programs. I think that is all I need to show you for the classroom, because there's not all that much difference from the code editor. It's just that you have an overview of what all your students are doing and the ability to step in and alter their code live for them. The ability to provide them with a program to start with. If you want to give them the starting base of an experiment, for example, you give them a program so they can run an experiment. They can then do data gathering using the program you've shared with them. Or if you wanted to do a debugging exercise where it's just not quite doing what you want it to do and you want the students to fix it, You can give them a faulty program and ask them to fix it, or you can give them a program that you want them to optimize, make it better, get them to move things around into functions and statements. We do use this. We use this software when we run our robotics club online during the microbit topic. It allows us to see what they're doing and help out over long distance. But we've also used it in the classroom as well, because it's allowed us to save everyone's data, especially when they've borrowed our computers to do their software. If they don't have a copy of this, they can't, we can't give them their files quite so easily. This way we can then retrieve their files afterwards and send them to them. The only thing left to say is thank you for watching this video. We hope you found this useful. We have had a lot of success with teaching about microbits in the classroom. We offer a lot of different resources and workshops that we will deliver as well. If you want any more details, please visit our outreach website. If you haven't got access to this PowerPoint and you can't click on the links on the screen, obviously, then please just search for Aberystwyth University Outreach and you should find us on Google. Thank you so much for listening.